anyway. Yeah, so let's go through the requirements again, just with some more visual aid. So, looking at the first one, we should have a main menu. So something like this, you don't necessarily need all of the buttons. So high scores is an optional. Editor is an extra, which is not mentioned. You can do it if you like. Help is just to help you understand the controls, and then exits the game. So base requirements here are that you have a start game and an exit button. So you can those are the minimal requirements. So exit, I will not click it. You will know what it does. So if you start the game, this is also the optional. So you can have multiple levels if you like. At the very least, start game requires you to have just start a level. So I'm just going to do the basic level. And then, so in here, you need to have Pac-Man animated and moving around the level, and you also need the same for the ghost. So it's not required, as mentioned, that the ghost have a texture or that the food have a texture, but it does look nicer when that's the case. And there's also power-ups here, so if you eat it, you can kill the ghost. You can actually cheese the ghost by keeping it in the corner. But anyway, so and if you die or win, so let's just die here. I'll be respawning, and I'll just go and die again. So the ghost here is also not moving randomly, it's using it's pathfinding towards you, so it's actually a little bit unfair sometimes. It doesn't use line of sight. Yes, and everything is done with GLFW and OpenGL. So yeah, so there's high scores is also an optional, so you have a list basically for each. In this case, it's for each level, so you can change the level. Yeah, so this is basically everything, all of the basics and all of the optional features and some extras on top of that example. So, and you can take it that far, you can take it further, or you don't have to take it that far, or if you don't have time, or if you need to work on your skills more. Yes, so apart from that, some tips on organizing the code and working with this task is most groups that don't do well on this start too late. So don't push it until the end, even though we have assignments in other courses as well. This one is tough and it's going to take you some time. It's got a lot to it. So if you want to do, well, you should start probably thinking about this today or at least this week to find a group and start thinking about how you want to organize the project and code and think about how you want to start approaching this, to start solving the harder problems like animation, texture, map loading, and collisions, so you can move around. So definitely do that. If you don't, you might end up with very little to the assignment. So this one was started on day 1, and it took 3 weeks to get there, basically. So it's better to just work evenly, but you'll have to organize this yourself. So next one is basically going to be on some of the code, because so far you've only been working with a single main file. Do not submit just a single really long main file here. It's going to detract a lot from the professionalism grade, part of the grade, because you want your code to be modular and you want to be able to reuse it. So some quick tips there is that the main file should probably not be much longer than this. Ideally, you can have more lines or less lines even. But you want to wrap your main loop in some sort of a class that basically manages all your resources, which also avoids you from using global variables too much. So in this case, solved it with a game class, which basically holds the window and other data about the class. So this is it's got initialization functions to initialize GLFW, initialize ImGUI, which we will have to talk about at some point for GUIs. At least we did it last year, so it would be helpful to do a lab on that next week probably.
Yeah.
And then an update function to update all of the game logic, and a draw function basically that ensures everything is drawn to the screen. So if we go to the draw function, it does a clear. In my case, it clears and swap buffers, and then there's a class that's a renderer, and that's basically where all of my OpenGL logic lies. So it would be nice for you as well to create a renderer class that basically holds all of the OpenGL state. So if I just go to that one in my case, the renderer here basically holds a sprite buffer, which is an unsigned or GL uint, but so this is basically the same as a gluint. It holds some other buffers, so basically it holds a lot of VBOs, it has a VAO, it has the shader program, uniform buffer matrices for projection and camera transforms. And then some load textures and also some more advanced rendering stuff. But basically it holds all of the OpenGL state, and it acts basically as a singleton if you've used that before, or you can think of it as a global because most systems will have to touch your renderer, and it's sort of one of those systems that you need to touch in many places. So it's actually not too bad to use it as a global or a singleton in this case. I would recommend a singleton, but because at least in that case you get to choose when it's initialized, so you don't initialize it until after you've initialized the workflow. And basically what this does, it has draw functions, it has load texture, it has get tileset texture, which basically loads the texture out of like a tile map, for example animations. It has load animation texture, so basically you have all of your utility functions for rendering somehow tied to the renderer, which is going to allow you to get access to all of your data from a single class, and you organize your OpenGL around this basically. So very little other things should have GL code than your renderer. At least that's one way to approach it. You can solve it however you like. I'm just saying what might work. So likewise, in the renderer has an initialize, which basically turns on, in this case, blending and some other, and basically sets up all of the VBOs and the VAOs. So that's all it does. Basically stuff you're already familiar with, just wrapped inside of a class this time. And you use the destructor here to delete and clean up your resources. And in my case, draw is just adding some data to a vector, and then we're sort of passing that data over later. So there's a submit work function that basically goes ahead and does the buffer data copy, which means you don't have to call buffer data every time you call draw, which is slower than just caching it all up and then passing it over. But that's for performance reasons, so do whatever approach. Start with the basic approach, and then you can tune it from there if you need to. Load texture basically loads a texture, but that's you'll look at how to do that later. But the core idea here is that you probably want to keep your OpenGL code concentrated, so like having a renderer class is nice. And it also has helper structs for vertex, instance vertex in this case, that help you, that it uses for the vertex data. I also have other classes for post-processing, and have wrapped, for example, a vertex array. I've wrapped that in a class as well to make it a little bit easier to work with. So you call a set attribute function instead of manually doing all of the OpenGL calls. So you can do that as well, and feel free to wrap OpenGL concepts inside of separate classes. For example, shader programs, you can wrap that as well, so you don't have to delete it manually. But that's up to you. You can work with the raw handles as well. But in the end, if you have some sort of a game class that that run the main loop and take care of updating and drawing all of your game objects, like for example Pac-Man and the ghosts, and so the main loop in this case is basically this one. So in GUI we look at that. So all it does, it gets the delta time, calls update draw, and pulls the events as normal, and cleans up and initializes first, basically. So see if you can create a game or application class that has a main loop and some set of variables, and that initializes GLFW and the other libraries, and then have a renderer for OpenGL, and the rest of your game logic you'll figure out how to split that among whether you create some sort of a game object system with components, or if you just use inheritance and create a base actor and then inherit from that, or if you use a component system. Yeah. So it's up to you how you want to organize that. But the main idea here is related to the OpenGL stuff, and that means try not to mix OpenGL code into every single class and have GL code have every sort of instance of the class called draw. Rather concentrate all of your draw code like in one place, so it's much easier to debug it later. That's basically the core tips. If you have any other questions that you know about organizing code or trying to set things up in like a bigger project, you can ask now or later. We will be here to help you with the assignment in the future. You got 3 weeks, so this is just an overview to like give you some starting points on what you might want to do. So if there are no questions, you guys, we should probably just start with the lab, and we'll help you around with that. Yeah.
Great.